start with just run the simple application that I prepared. Just looks, or no, we start with the goals about clustering, because clustering has different goals in the Java, in the servlet world, or in the server world in general. And yeah, so what do we want to achieve with clustering? So I think one of the main reasons when clustering is to do some load balancing. So if one server gets too many requests, has too many sessions, gets out of memory, we need to somehow scale up onto multiple nodes. And in order to do so, we need some kind of load balancer in front of the application, which could basically be done without any kind of session serialization, because you can have multiple nodes that run and just use sticky sessions, and every user can work in a specific node. But at some point, maybe you want to scale down, or one of the nodes goes down, and then you need the sessions to migrate to one of the different nodes, and then we need something called session failover, where a session just continues to work on another cluster node. And for this, we always need to be able to serialize and deserialize our sessions. It's something which is the normal thing to do when doing clustering. I think most of the clustering solutions work with session serialization in one or the other way, and in Java, it's by implementing a serializable interface. I think it's nothing new to you. And make sure that all the information you need is restored after deserialization. And in the end, of course, we want this to happen, or we want the possibility to do this automatically or dynamically. So whenever we create a new node, it should maybe take over some of the load, or at least take over new connections. And when one node goes down, it should the session should be distributed among the other nodes. This is mostly part of the load balancer again, to make sure that the load is distributed evenly. There are many load balancers, so I will not go into a specific load balancer vendor or load balancer type, because everyone has their own load balancer. They all have their ups and downs, all their advantages, disadvantages. Just talk about which features these need, and I think it's something basic. We will see how our sessions migrate from one to the other node if one of the nodes goes down, or if we start a new node, and see how new sessions can go there. There are some other goals with clustering. For example, sometimes you want some kind of fail tolerance if really one node completely crashes. It's something quite hard to achieve, because what happens, what could happen is that the node crashes while your database operations have already been committed to your database, but the session serialization is in the middle of serializing, and then the node crashes because of a power outage, and the session is only partially serialized. Then this crash session can never again reappear somewhere else. So this is something we can't do with ZK, because once the component trees are changed and updated, they need to be synchronized with the client side, and if the client side already has parts of the request, part of the changes, and the server side is out of sync, then the following requests maybe don't work anymore, because the components are gone or don't match. And this is not only with also because we have multiple browser tabs which all share the same session in ZK. So if these kind of things happen, I think you can't do this. Or I don't know, if you have a scenario where this works, let me know. Maybe we can improve this idea. But right now, I'm not aware of doing this. So it's mostly about the good case where we want to upscale, downscale on demand. When everything is working, we want to shut down a node. We want to start a new node of the cluster. So as mentioned, there are some limitations in ZK. For example, because ZK uses Java objects internally to synchronize access to the component tree, these objects need to be the same instance of the object. So you can't, that's maybe here, that's the first one. So you can't freely create new objects. Or you can't just deserialize multiple times during one desktop operation one update of the browser, because the object instances need to be the same, and whenever you deserialize, there will be a new instance of this object. So that's why the default Spring Boot Redis starter won't work. I'll demonstrate this in a minute, how this fails. Another important thing is we need sticky sessions, mostly for efficiency and for reliability, because CK sessions tend to be quite big from time to time. So if you constantly switch between nodes of the cluster, you will have just bad performance, because the data has to be transferred from one node to the other. So it's definitely inefficient and also not reliable, because you can't prevent concurrent access. Because there are two browser tabs, maybe they have some server push running, and one browser tab is updating in the background and one other is updated by the user, and both of them try to write the session to your serialization storage, and suddenly only one of the two sessions can win and the other one loses its updates. So for both reliability and efficiency sake, use sticky sessions. This is mostly done by either session ID or by IP address, depends on the load balancing capabilities. But this is a default feature that you should always enable, otherwise, if you're lucky and it runs, it will not be efficient. So don't use strategies like round robin. Always use sticky sessions. It's still possible to migrate from one node to the other, if you can ensure that all the previous requests go to the current node, and when the node goes down, all of the other requests, all of the following requests go to the new node. Then there's only one time where the migration happens, and maybe there's a small delay until the next request can be served, but it will not be a concurrent access. It will happen after the previous one. So this is possible, so you can migrate between nodes. And as mentioned before, ZK requires identical session instance, and within the session, identical desktop instances to synchronize and to prevent concurrent access to the component tree. And in the same way, so you need to avoid unnecessary deserialization, which is both useful for performance and for the stability's sake. There are other considerations, I think, but this is something maybe some optimizations we talk about later, because I don't really have a solution for this yet. But it's something you might consider, that session serialization can be happening in the background, so it doesn't need to slow down your request. It's something we will see. And also, in the best case, maybe you can keep your sessions a bit smaller and have some alternative recovery strategy. So not storing a big session in the in your session storage. In this case, we use Redis, and store something smaller, ID token or some kind of string fragment or configuration ID that has your information. Maybe you have it in the database, so you can recover the screen the user was currently at. If you don't need the finest detail of the cursor position where he was, these kind of things, you might just recover the current view, if this is applicable to your current application. So maybe this is a cheaper way of dealing with session failover. So yes, so let's look into the simple application. As always, I prepare some small runnable application. In this case, I chose again a Spring Boot application because it's easy to run, and because Spring Boot has these built-in functionalities for or built-in starters for Redis and for session storage, and also because it's popular and people tried it and failed with the default setup. So I will demonstrate the default setup, and then we will see how this fails. So we have simple COM. What we do is we use the normal default Spring Boot starter web. So right now I think there's a newer version available, or I chose the version a few months ago because I prepared this already since a while. And what we are trying is to use the Spring Boot starter, the Redis, so the default Redis implementation of Spring Boot. I think initially we start just by disabling this, just to see how the application works without it. and let's just run it. So we just run a simple node, a single node. The node should be, now it's failing because of compilation errors. I hope it can still start somehow. No, it doesn't let me start. Okay, then I just need to enable at least this dependency. Something I want to show later, but I need it for running. Okay, just run again. Okay, there's my Springboot application starting up. It takes a bit longer when screen sharing, as always. And following stack trace, is it currently running exception? Considering Redis connection factory. Redis session config. Where's my configuration? Oh, it's disabled. Just a minute ago this worked. Yes, I think I uncommented the wrong thing. So this is just the Redis starter. This is only for Redis for Redis connectivity. I need this, and I want to disable. Yes, that's one. Sorry, I was a bit on the wrong side. So I want to keep the session call because some of my classes need this, but it's currently not enabled because my configuration is disabled. So it's just a vanilla Springboot application. Come on, give me something that runs. It's always good to see if something fails. Then you have also some idea about what can happen during application, during your own development, and how to deal with errors. But now, application starting up, and if we open the browser, don't need this one, we can go to our localhost port 9091. That's the port I chose for this application, and it's running. Just close the developer tools for now. And I can click a button and a counter will increase, just indicating that the current session state, so we know that we currently clicked 9 times in the current session. If I stop my application and restart it, it should naturally lose its session because I haven't enabled any kind of session storage yet. So if I click the test button, it should just tell me the session is gone. Would you like to reload? So that's what ZK does by default. If we then start some kind of, if we then start the Redis cache, so we just start Redis. This is the default Redis binary. I just downloaded it and compiled from source. I think that's what they provide. I didn't find a binary for Linux. I think for Windows there are some binaries available. It's just really the default Redis in standalone mode running on the default port, so that Springboot can connect to it. And once we try to connect to it, we of course we try the Springboot starter Redis. Don't need this for the moment because it's included as a dependency anyway in this one. So the Springboot Spring Session Data Redis is this default configuration, and it will connect to localhost at the default port. Okay, and then we just run this again. We should see that our Redis gets a connection once the application is started. So here it says it's accepted a connection, and now it says 2 clients connected. I don't know why it's 2, maybe it's some kind of fallback strategy, but it's connected. And now if we try to use our application and we reload the page because it's what's gone anyway in the meantime, we see it's creating a new page, and it also created 3 keys in Redis, so it stores something in the session, or it stores the session into Redis. But if I try to click a button, it works sometimes and sometimes it fails. There are just things not working properly. You see, it's losing my updates, and this happens because the default implementation of the Redis I think Spring Data Redis is deserializing the object very, very often, and at this point ZK will lose track of the updates, and it just changes the wrong object, and then we just don't see any updates anymore. And in this case we were lucky, because normally it doesn't find the session anymore. So if we refresh the page and click the button again, it's just gone. And we click again and run, it's gone. So these are some kind of symptoms. You see it's creating too many keys, because it's, I think, serializing the same session multiple times into Redis, and it's picking up the wrong key in the end. So the default is not what we want, and it's unfortunately out of the box, not working. So instead, and that's now the complicated part, I had to implement my own session storage, because you can't use the default storage. We still use Redis, but manually, and we implement our own session repository. For this we have the session configuration. Just go quickly over this one. And where is the dependency? It's here. So enable HTTP Spring sessions. Where's my main dependency? It should be loaded Redis. It didn't load it yet, so there it is. Spring session core, and now the dependencies are here. What I'm doing is on the it's a Spring configuration Java class, so nothing special. It has it enables the Spring session handling, and enables some scheduling to clean up expired session, because now we deal with our sessions ourselves. So we implement how sessions are created, how they are saved, and how they are destroyed. And Spring Session offers a very nice interface for this, which is not very complicated, and it doesn't require a lot to implement your own session storage. We just give it a default timeout, and we say every 10 seconds check if any of the session is expired, and then do something. And the default session time we set to 30 seconds, so we have something we can wait for during this talk. Alright, and then we have the session repository implementation. So you can see it's not really big, it's 100 lines of code. And part of it is the cleanup, where it's just iterating over all the current sessions, and it's checking if the session is expired, and if it's expired it will remove it, both from the local session cache and from the Redis, from our Redis instance. So this is, I think, straightforward. It will just make sure that cleaned up sessions are, or that the expired sessions are cleaned up. And then the interface for session repository, as you can see, is really simple. It has, most important is create session, to create a new session. You can specify what kind of session implementation you want to choose. It has a save method, where you decide how to save and when to save your session. It will just ask it quite often, so you have to be very picky about when you save. And there's something called the method find by ID, where you have to retrieve the session from the Redis if you don't have it in the memory cache. As mentioned before, we need the same instance. So in order to have the same instance, we just cache the sessions in memory of the current node, and only if we need to load it from Redis, if we fail over to another node, we load it again, because deserialization costs some time, and we don't want this all the time. We will try to avoid unnecessary serialization operations. And whenever we have the object in memory, we can just return the instance, and that's the fastest way we can do during the method find by ID. And delete by ID is just also clearer when the session is out of when the session is expired. Maybe Spring decides to call delete if our cleanup wasn't faster anyway. So very simple interface for methods, and in order to implement this, I just did the same thing for creation. I create a session, I implemented my own session class for better logging, for better so I can get some useful logging information on the console down here. We'll see this in a second. Saving the session is maybe the most tricky bit, because here I will check if a dirty attribute is set on the session, so I don't always save. So we have some kind of way to decide when we want to save, because as I said, this method is called quite often, and we don't want to save every time it's called, only when we think that something has been updated. And once it's saved, another node can fail over and load the session again. Another cluster node. And yeah, there's some hash map. In the end, there's just a hash map which has the sessions. And if the session map does not contain the current session, it will load it from Redis. Otherwise, it will return the instance directly. And when saving, it will do the same based on the attribute. So we have this kind of control. And also I'm measuring the time, how long it takes to save, just to get some idea what the price is for this kind of saving and loading a session. So same here, if the local session cache does not contain the current session ID, it will just load it from Redis. And as you can see, the implementation is very simple, almost trivial, and the rest is just logging and debugging. So I think it could be condensed down to 60 or 50 lines if you need some kind of smaller class for this. And delete by ID, just remove it from Redis and from local session cache, also trivial. Just to show you the current session, what I do is I use the implementation provided by Spring, which is called map session. So it's just a key value store, a key value map for session attributes. And I can add some extra information about what is my current node name, what is my start time of the node, so I can generate my own session IDs for better debugging. And the rest is just delegating to the map session. So you see there's really no code implemented here. It's just my own object, so I have better session IDs that are easier to track when we look at the logs in a second. The session dirty markup is just setting a session attribute. So whenever we decide, in this case I said whenever a ZK execution is done. So the ZK execution is the abstraction around the request response cycle for Ajax and for normal page requests. Whenever you try to update the component tree, you are in an active execution. And whenever this is done, so during the cleanup phase, I will tell the session this is dirty, so that the session is saved after this. And by default, Spring session will save when the request finishes, so it will try this at the end. And I just set an attribute to true, could be anything. I just set the attribute, and then I know I have to write. If I don't do this, you could also implement your own way on setting this attribute at any time during your lifetime. Maybe you already know that you're not changing anything, so you don't save the session at all. If you have this way of optimizing, you can fine-tune this. There's nothing. It's just a marker property that is there. There's the configuration, the session, nothing about the session. The application, the Springboot application, just for completeness, is just disabling one of the caches, so I can change the root file directly without restarting the Springboot application. The rest is just default Springboot. And my view model, also trivial, has some kind of click counter variable, a getter for this one, and it has a button that is logging some information so we can see which kind of objects we are looking at, and also how much we clicked. Okay, let's talk enough, let's run this. I hope I enabled everything. Just double check the session repository config is enabled. Yep. So if we run this one, we just restart our Redis, so we have a clean Redis cache. Redis is really fast. It's just a normal native binary that launches in milliseconds. It's really no problem to restart this. if you're not worried of losing your cache, of course. So for development purposes, this one is a really nice tool. And now we can load our session. We can see one client is connected. There is one key in the current storage. And if I click my button, then the counter is going up. If I stop my node and restart my node, if we are faster than 30 seconds, it should not invalidate the session in the background. And if I click my test button, it continues to work. So the session already survived a node going down and restarting. If you don't want this gap where something is offline, you just run a second node, and then we check if it's also working at the second node, or if the session fails over to the new node. No, can't do this yet because we haven't set up the load balancer. So right now we only have one node, but the node is already enabled to serialize, deserialize the session on demand. And in the logs we should be able to see this, because this is my second restart of the session. We see the first click I did is it had to do find session by ID. It loaded the session from Redis, and it took, in this case, 0.7 seconds. And subsequent calls just work directly from the memory cache, from the hash map, so it doesn't have to load from Redis again. And from time to time it needs to save after the session has been marked as dirty. And the saving in this case is quite fast, at 0.08 seconds. It's a number, so you have to consider that this overhead happens. And that's what I meant. You might want to run this in a separate thread in the background if you can live with the chance of concurrency, that maybe the session gets changed while it's trying to save it at the same time. But since users are frequently working, the chance of losing this data is maybe small enough to be okay. And you see subsequent saves are a bit faster. Now you see up to 0.009 seconds, so it can be fast. Because right now the session is quite small, and we see in our Redis it doesn't use a lot of data. And now in the meantime, my session has gone. Because I was talking too much, you see the session went down. The session storage, the Redis storage went down by 100 kilobytes roughly from my session. That was gone. So if I click again, it's no longer there. And it will create a new one. It will reload, start up from 0, and we have a new, see here, something is gone, and then it creates a new session, created a new session. So that's the serialization. So now once the serialization works, we can recover a session from Redis, we can save it and load it. We can also enable load balancing. So for load balancing, I used a tiny tool from NPM. It's from Node. It's called Node NPM Load Balancer. So I just started. And the load balancer configuration is also trivial. If we just check, the load balancer module is called Load Balancer, as the name says. It's a trivial, convenient load balancer for demonstration purposes. Don't use it in production. So this is not production ready, but I think any load balancer, or most load balancers work in the same way. This one is just the easiest to set up and to demonstrate during this kind of session. And also I didn't want to spend too much time in complicated setups. And the configuration of this load balancer is like this. I configured two nodes. One is for 1991 and one is for 1992. And currently we have one node running on port 1991, and the other one will be running on 1992. So once we start the second node, we have a small cluster running. So now we have two Springboot applications running. Just clear the logs so we have something fresh. And clear all. So as you can see in the background, it's just trying to clean up sessions. Right now there's 0 sessions in this node and 0 sessions in this node. Also we should see here there's 0 keys in the Redis cache. And if we refresh our screen, we should have 1 session in the Redis cache. Yeah, there's 1 client connected, but now we need to connect to the load balancer port, not to the cluster node directly. And the load balancer port is 9080. So now we're playing a bit of roulette to see which node the load balancer is assigning us to. Okay, in this case the load balancer chose Redis node number 2, the ZK Redis node 2. So we can click the button and everything works. If then for some reason node number 2 goes down, now we just stop node 2. It's gone here, shutting down. Node number 1 should take over once we access the session. So we try to click. This shouldn't have happened. So let's try again. We test what's wrong with this node. Okay, let's start okay. We just stopped everything. Maybe I wasn't completely clean. How to clear all the logs and the logs. So we start node number 2, we start node number 1, and we reload the page. Right now it's still everything is starting up, which is okay. And come on. And now it should be up. Okay, so which node got the session? Node number 2. Okay, so we increase the counter a bit, and now we stop node number 2, and then we click the counter some more, and now we see it worked, and node number 1 took over and loaded the session from Redis. And now if node number 2 goes up again, so we're starting node number 2 again, the load balancer should keep this one sticky at the current node, at node number 1, and it should continue to serve the request at node 1. Just go to the bottom, so we see the logs writing. Yeah, it's still writing to node number 1, and only if node number 1 goes down, so just here stop node 1, the session should go back to node 2. Yeah, so it's still increasing the incremented counter, and it's back working. So now we've basically demonstrated the downscaling, upscaling with a single user, and we can test with multiple users, which we will do. I have prepared a small automatic test case that will simulate multiple users running at the same time, so we can see how these automatic tests behave while nodes go down and up again. And we also see that the session is still the one we started initially at 1643. Click quickly, otherwise we'll lose our session, which is always the starting time of the server. But if we, for example, delete our session cookie and create a new session, it should get a new session ID. So we say cookies, localhost, clear all the cookies. And if we reload, which node did it go to? Yeah, we got a different timestamp and a different timestamp. My counter is always starting at 1000 at 1000, so that's why I have the timestamp in front of it. This is all part of the session ID. We have not much time left. So we see we currently have 2 sessions running, and now 1 session expired, back to 1, and we should see the same reflected in Redis. Yeah, it went down from 2 keys to 1 key, and the session went down. Now we should look bit at the timings when the session gets larger. For this, for example, we can create just a larger number of list items. Just use 50,000 list items instead of just 50. And I think I don't need to restart. Just observe the timings this time. So we reload. So what we have now is we should see that the cache size increases significantly. So now we have 1.3 megabytes used in Redis instead of just 600 kilobytes, because we have a quite large session now. And what we see in the timings, where do we see this? Which node is currently running? This one. If we click the button, we see that the saving takes a bit more. So it's now 0.02 seconds. If we scale this up a bit more, maybe take 500 million. I restarted. Why not just stop everything and only start one node, so we don't have too many log files to observe. Okay, so now if we load this page again, okay, and now we test again. Now we see this scaled almost linearly. Now it takes 10 times as long to save the session. And this will become significant if your sessions are too large, and there is no way around this. If you have to serialize a session, it will have to go through the serializer. The only thing you can do is do this in the background or in a separate thread to avoid blocking the response for this time. But here, for demonstration purposes, it's good to see that there is this kind of impact, that the session size affects the serialization time. And that's why we try to prevent this from happening too often. Another thing we will see is that this, when we reload the page, we will see how often it's preventing from saving the session, because we have this dirty flag. The dirty flag avoids saving, so it only saves once after the dirty flag was set. The dirty flag, where is it here? Dirty flag, and then it's calling find by ID quite often, and as long as it finds it and just returns the instance from the local memory cache, it's good. And it even prevents saving, which would otherwise it would try to save 10-20 times, because there are many requests in the ZK application that load other resources that are still maybe bound to the session, or try to load something from the session, like the locale. If you load locale specific resources from ZK, there are many calls to get current session, and then it's good to have this being returned from the local memory cache, and then afterwards it's also trying to save it. And this is something we need to prevent all the time. So this implementation already avoids this kind of performance problem. But still, saving costs. But imagine this one happening 10 times or 20 times just for a page refresh. Then your whole server is really busy, because this is busy time. This is when a CPU is at 100% and doing something, serializing code. There might be some I/O involved, but it's really busy during this time. Or a thread is completely blocking during this time. But you have multiple cores, so it doesn't affect all the other processes. But still, that's significant. So always a good idea to keep sessions small. In this scenario, for example, because we have load on demand, it's not creating all the components all the time, but it still has the big model in memory of all these list items, of the list item data objects. So we can produce a few more list items by scrolling down, and then we should see that the number is sometimes getting larger or bigger, but it's still not too bad. So the load on demand has a big big benefit here. So we just put this back to 50. Yeah, let's see. Where are we? General dependencies. What? Yes. What can we do? Yeah, as I said, the load balancer I'm currently using is not using session IDs for how to say it, for the sticky sessions. It's using the IP address, and that's why I can locally not easily test this with multiple sticky sessions on different nodes. So I have to use some kind of trick. I just enable my Wi-Fi, my wireless network, and then I have 2 IP addresses, and I can run JMeter tests with different host adapters, so I can simulate this and see how this behaves. And again, we will just start both nodes, and then we just run an automated test case. I don't know where I have this one. Is it here? Now I have the run command. The run command is local start commands here. So I have one test case that's using my local IP address 165, and the other one is using the local IP address 175 as the adapter to connect to my server, so that the load balancer has 2 different IP addresses to do load balancing from and to do sticky sessions with. So if we run both of these tests, we should see that we should see that if we're lucky, the load balancer will choose 2 different nodes for these, if the load balancer is good enough. So we just run once, and we open a new tab and just run the other one. So now we have 2 JMeter tests running, and if we are lucky, it's going through 2 different nodes. Clear once and clear here. We should see some activity. So you see it's clicking a button, it's increasing the counter. I think it's clicking every button 10 times and then closing the browser tab again, this test. So we should see the number increasing, 1, 2, 3, 4. And on the other node, it's also doing something with a different session. So we see this one has a session ID node 11003, and the other node has a session node 2100, so 1000. So 2 different session IDs. And if now one of the nodes goes down, we should see that both of these sessions migrate to the remaining server. So just kill node number 1. And now we should see that one of the sessions migrated to the other one. Now here we see, now there's the session from node 1 now appeared on our Redis node 2, and still the other one is also running. So now both are running to the same node. If the load balancer is clever and you maybe have 10 nodes, it should distribute the sessions of the node that went down evenly on the other ones, and then remain sticky to this node. Yeah, what we see in the logs of the cluster of the test, we see there's an error. So whenever one of the nodes are down, also, no, here we don't see one, because this one didn't go down, but this one went down. This error is just the thing that you see when you are a normal user and your node goes down and you click an Ajax button, it will ask you, would you like to retry? And then you can click OK, and if the failover worked properly, it will go to the new node. Or it will continue running. So if we can test this, and just open our browser. Just reload again. So we click test. Perfect. So now suddenly all the nodes go down, and we click test. It will say server is out of service. Would you like to try again? And then suddenly, in the meantime, a node goes up again. Just need to wait until it's resumed. And then I would like to try again, yes. And in this case, come on. I did something wrong. Somehow it didn't work. You see, things are still a bit dodgy. I don't know if this is the load balance or if something else is interrupted. We just try again. Just test, count a few numbers up, shut the node down. We stay in the waiting state, and then we restart the node. Okay, come on, give me okay. And okay. And now it recovered. So I don't know if this is still a bug, but at least there's a chance it can recover. Otherwise, you have no chance. I think these are the areas that need improvement in finding out why things happen. Maybe it's my load balancer who's crappily configured. Maybe it's the fact that I'm running with a local host and my local network adapters. I didn't really debug this too much, but you can demonstrate the good cases, and you can check if the bad cases have a chance of working, and then maybe test with the better equipment to see that it is more reliable. Okay, I think I will skip this one, otherwise I don't have enough time for questions, because I had some virtual machines where I could connect from different IP addresses. This is, I think, a bit too much. So that's where we currently are. I will provide this kind of source code. There you will see the JMeter test. I'll just show you quickly what the JMeter test does. So, because it's always important to know how JMeter tests in ZK work. Just run JMeter and open the test case. Okay, we just file open recent. I just open. Now where is the window? Load balancer, source, target, concurrent, open. So here we have the test case. It's really simple test case. So it's loading the main page. So it's loading the main page, just a / URL, and it's just clicking a certain ID. So here it's looping 10 times to click a button. So it's sending the click ID to the component with UUID Z_5. That's a different topic of how to write JMeter tests. In this case, I used the static ID generator, which ensures that the buttons for the components have the same sequence of IDs on a page. So I can always click Z_5. And then in the end, remove desktop. And it's very important. Whenever you write a JMeter test case, be sure to remove the desktop, because that's what a browser does by default if you close a browser tab. If you don't do this, you will test a memory leak. your load test will test that every browser of the users are crashing without cleaning up desktops in ZK. It's a valid test case, like testing for DOS attack scenarios, but it's not the normal use case. So be sure when you do load testing or performance testing, always send the remove desktop. Otherwise, you're simulating something that does not work, or that is not a normal case, and you just see memory increasing, especially with longer session timeouts. You will just see that during the lifetime of your test case, your memory will be at the peak all the time, because it's constantly creating new desktops, new sessions, and without cleaning up the old ones and leaving the memory until the session times out, instead of cleaning up the memory when the user closes the browser tab or navigates away. Okay. I think we have 10 minutes for questions. I assume this is, as always, a lot. So let me see. If something was unclear, I can show some code in more detail, or if you have a specific question, let me know. Because what do we have? Performance testing, JMeter has interactive demonstration, walks through example code dependencies. Yeah. And if you want to say something, you can unmute yourself or just write in the chat. And if you don't want to be recorded, let me know, then I will stop the recording before you have your question. Also valid. Stop this one. Load out. I think I have a README. Yes, that's one thing. And when I provide the source code, it will contain some information on how to set up, not how to set up Redis, but at least how to start the Redis in this scenario, because I assume you have Redis. Will you upload the training record? Yes. But you need to, because there's new people joined, if you want the recording, please send us an email. Don't send me your email address here in the chat. Send us, just reply to your invitation email that you got from, I think, Susan, and just tell me, yes, I want the recording, and you will get it. You'll get a link to download. As in here, the commands are explained how to install the load balancer from npm, how to run the load balancer, and Redis is just complicated by itself to install, so you just follow the instructions how to install Redis. As I said, it's just a vanilla Redis without any specific configuration. And then also how to run the nodes. I just see there's a typo, it needs to be a dash, because that's the parameter I have configured. Yeah, node name is dash. Okay, it's just to give some better. The node name is necessary to have some better debugging, to see better log messages, and these nicer session IDs here. That's where the node ends up. Good question. Server push via Ajax should work. WebSockets, I think, did not work when I tried this. But I haven't looked too much into detail yet on this one. So this would need more testing. But in theory, there shouldn't be a big issue, because the webs, or does the WebSocket work? Because the webs, I think my load balancer didn't support WebSockets, so I couldn't test this. So if you have a better load balancer that allows WebSocket connections, then let me know, because I'm still looking for an easier way to set up a load balancer locally that supports all these things. So, because I don't want to go to some kind of cloud service for load balancing, just for local testing. One customer told me there's something called Traffic, which is some kind of load balancer that seems to be quite good. There are, I think, lots of hardware load balancers and in others. So this is that's I would say a science by itself, how to do load balancing. Important for ZK is it needs sticky sessions to be efficient and to be reliable. So that's the main takeaway. Sticky sessions, and avoid too many serializations and deserializations. And if you can, implement a session storage that only saves sessions when the node goes down gracefully. That's the most efficient way. Keep everything in memory until the session goes down, or the server is stopped, or the load balancer decides to reroute, maybe sends a command to the server to say, here, you're no longer serve your sessions, please serialize everything, I will reroute the traffic. I don't know if these scenarios exist in practice. Oh, there's a new question. What happens if a new node is added to the cluster? Update new code. I think I demonstrated this. What happens is that if a new node is added, the load balancer should be clever enough to route new traffic to this node if he decides that this node should receive the request. ZK doesn't even know about it. When ZK receives a request, you see on port 90, 91, 92, 93, 94, 95, whichever port you want, is it a good idea to make transient via variable like Spring Service or a Feign client? What is a Feign client? Can you maybe I think there's a typo. Thanks, Victor, for the tip about Apache server has a better load balancer. Yes, but it's, oh, this is a question mark. This is a question when building Springboot as a load balancer works better than npm load balancer module when building. I assume there's a lot of better things. It's just more complicated to set up and more complicated to share as example code. So that's why I'm sharing this one, because it's just working easily. But back to the via variable question. The one from Estuardo Garcia. Can you try to type again what this last word means? Feign client. I don't know this word. Everyone publicly. This is feign client. That's the wrong target. I want to send to everyone. How to send to everyone publicly and privately? How do I change the target? Sorry, the chat doesn't work. Estuardo Garcia, if you still have your question, can you please specify what this means? I mean, a service to make a service transient, I think is a good idea, because you can't serialize a Spring service easily unless it's a proxy object. Because the service is an instance that runs in a specific node, and if this node is deserialized at another node, I think it doesn't make sense. So you need to ask Spring to rewire this node, and I think you can use these what are they called? Proxy scoped proxies. I think they're called scoped proxies in Spring. Can we use Spring Zool proxy instead of Apache Load Balancer? I don't know. What is a Spring Zool proxy? Never heard of this one. A feign client is a declarative REST client interface. There's just more special words. A declarative REST client interface. I think the interface can't be serialized because it's an interface. I'm sorry, I think I don't know the terminology here. Just like a feign client. Yes, let's get back to this later. Yeah. Yes, Zool Spring Maven dependency module allows URL redirection. Okay, yeah. If you have, this is again private message. Okay. Not everyone can read this. Sorry, I'm talking about this load balancer because I get some tips about which load balancers might work better. So I'll keep this in mind. Maybe I'll try this out at some point. Spring Zool. Okay. Okay, so if you have additional questions, you can also write an email to our sales team. Arsuniga, wake up! He woke up. Hello. Meeting is over. Sorry. Okay, I think it's time to stop the recording. Stop recording. Okay, so everything you say now is off the record. Oh, 4 a.m. in Peru. Yes, I understand. So you can you can request the recording and watch it again. Yes, I will share the source code linked of this demo now. I don't have a link to this yet. I haven't uploaded this code anywhere, but I will give you the code. Yeah. Yeah, as I said, the README contains some information how to set it up, how to start this. There are the local start commands that help you to start this up. If you have Redis server installed somewhere, you will know how to start up Redis, and then also how to build the load balancers. And if there are questions, let me know. But the principle is, I think, should be clear. And yeah, I would also like to thank everyone for watching. And I hope you don't have the same problems or you don't go through all the same process like some other people included before coming to a solution that maybe works, or maybe before deciding that maybe the clustering goals are not achievable if you have something very specific in mind. Okay. Yes, thanks again for the feedback. Yeah,